and false news has become all too common. More alarming, some media outlets publish
Welcome back, everybody, to another episode of the Post-Truth Podcast episode. I'm here with my co-host, Johnny Stewart, and also here with our guest, Sam Fisher. We're going to be talking about a number of topics today, but I definitely want to delve into some subjects related to, data and AI and machine learning. A lot of stuff that floats above my head, floats above a lot of people's heads.
Yeah.
So that's why we're really excited to bring you in today. I've known Sam for a couple years. We worked in the same building, doing different jobs, of course. I was pouring coffee and slinging drinks, and he was working on hiring mind stuff, and I always really enjoyed talking to you about that type of stuff. So we definitely want to, touch base on some of that, but also want you to give a little bit of a self-introduction for those who don't know of you or haven't met you. It's always interesting, too, to see how people will introduce themselves. So go ahead.
Sure. I'm Sam Fisher. I'm a data scientist, which is, I guess, what qualifies me to hopefully make some informative statements about AI data and how that affects our individual lives. I work at a startup called Stratify, it's called like a fintech startup. So it's financial technology, right? Specifically, these are like technology startups that serve the banking industry. And what's interesting about that is that the applications of machine learning in banking are really highly sensitive. Like, they're regulated, as they should be, because you're making these decisions which have a large impact on people's personal and financial lives and their prosperity. One of the most important being, is somebody going to be approved for a loan or not?
Right.
I can see how this could create a lot of privacy issues for the future. If our financial sort of expenditure is studied, and maybe that's something we'll get into later, but that's the first thing that came to my mind when you talk about fintech and things in that world. So much of our lives are tracked already. Maybe we'll get into that, but
yeah, we can talk about that.
Yeah. So I've been excited about this episode ever since we talked about it, and Ben mentioned bringing you on. This is a topic that he and I both are really very interested in, and I think a lot of audiences too. So I don't know. Could we start at just a high level? Because I know CES is going on right now, the Consumer Electronics Show. And right now it's sort of just saturated with all these AI, products, whether it's a coffee machine or, there's so many different things that are out there. And do you have any insight into sort of the consumer side of AI, the broader picture of AI, before we drill into more specific topics?
Yeah, I think it's probably helpful to make a delineation there about some use cases of machine learning. I've spent some time on kind of the natural language side. That's sort of the academic term for what you're describing. Say if you have an interactive coffee maker.
Sure.
As you started to describe at CES. So, and of course, there's a big explosion of attention on ChatGPT.
Right.
So that work revolves around how can we make language an interface to computation. Like, computers have all of this power.
Yeah.
They can answer complex questions.
Yeah.
They have a lot of, if we provide it the data, it has a lot of data at its disposal, and it has a lot of raw processing power to do math against that data. But the way that we naturally think is in language. So we want to take a question in language, and we want to get an answer, from the computer. And this is a really non-trivial problem, right? To state something in language and have that, be compiled all the way down to something that a computer can act upon and give us back information.
Binary at the very root, correct?
Right, yeah. And there are levels of computer programming languages, right? So you might see Python, and then beneath this, it's compiled down to instructions that a machine can actually execute, called machine code, right? And there's the layer of the operating system. But anyway, the idea is to somehow translate between us, people that think in language, and them, uh, machines, which are electronic circuits, which
Yeah.
we can think of as physically implementing logic.
Mm-hmm.
They do logic. That's how they deal with information.
Mm-hmm.
Do most people when they're programming an AI, do they have a common set of tools? Because I know, and one subject we talked about was blockchain, and when you're working with blockchain, there's a couple of different coding packages you want to use, and then people just make different products with those packages. Do you feel like it's the same with AI, or does everybody just start with a different approach? Like, let's say ChatGPT, what did they use to program that? Do you know, like JavaScript? I mean, or do they just have their own like in-house code that made it what it was?
I don't know. I don't know if that information is actually publicly
Mhm.
available. In some sense, I don't want to say it's trivial, right? Because it's not. What tools they use do matter, but there would be ways to, arrive at that end result through a variety of different programming languages or programming tools.
They may have a proprietary way of doing that. You're
I-
saying like that's
I think the key thing with
Yeah.
OpenAI is the combination of the algorithms or the data, right? And particular emphasis on the data because that gets underemphasized. So in order to make ChatGPT, OpenAI has to have this huge data set which maps responses from the chatbot to human feedback. This is the reinforcement learning with human feedback concept.
or
Yeah.
we teach it as it goes, right? And it learns from all of us together and improves its responses. All right.
Yeah. So with the kind of online learning approach like that, which is, learning as you go, you can think of it that way. And so you can think of the data set that the algorithm learns from. It learns what response is the ideal one, is constantly being updated. So that's also part of the data asset of OpenAI,
Mhm.
if that's indeed how they're training it.
Yeah.
Plus, in like the ChatGPT, it's not when you try to pester it about, let's say, facts or quotes
Mhm.
or what do you call
Give
it,
it the right
biographical
in-
references. It
Yeah.
tells you, hey, I only have access to database before like
Yeah.
2019, 2021. So a lot of people using it don't ever think like, if I'm asking this thing current facts or maybe scientific questions that have already been updated, right, because of new studies, some people don't even realize that like its initial database is already just a couple years old, so it has nothing up to the present, right? And then you have people using it. It's crazy because they're using that with outdated information to then do academic work.
Yeah.
Or to, it's the new Google.
I was gonna
so people are going to
say,
it for answers.
It does that, but it also will do like up to the moment revisions. I can't remember what I was talking to it about one time, but I was talking to it about something, and it gave me an answer I knew was incorrect. And so I explained back to it what the correct answer was, and it quickly kind of came back to me, and it was like, "Oh, you're right. I'll update my." I was just kind of like, "This is interesting." This was in the early days of it,
Yeah.
which I don't know, was a year ago maybe.
Yeah.
But I don't know. It's interesting to think about the information that's being aggregated, how it's being deciphered, and then put back to us. I mean, that's
Yeah, let's break that down a little bit.
Yeah.
There's a lot of recent work which is oriented not towards necessarily improving the foundation model, which is the thing, when we talk about the data set that only goes up to 2019,
Mhm.
this is used to train the foundation model, which is what it uses to fundamentally understand language. And understand language really kind of boils down to this probabilistic interpretation where it's like, what words are likely in a certain context. If I say, I am going to do a sport called, such and such, the likely words that fill in that blank are going to be names of sports, right?
Mm.
And other terms are going to become less like. So this is sort of the basic building block of that. You have these huge data sets and build up ways of encoding language into, what we call tokens, right? So the tokens are what we have those probability distributions over. And the end result of this is kind of the fundamental breakthrough in large language models through tools like transformers and the attention mechanism that allow it to seemingly understand language. There is a lot of recent work and also not so recent work, which is augmenting those foundation models to give them other ways of understanding. And this is really cool because it's something that's a lot closer to kind of your everyday app builder than to somebody that's actually going to go redevelop a foundation model, which is going to be very few people with kind of privileged access to massive amounts of data, right?
Mm-hmm.
I'm sure people would disagree with me on that because I bet there are independent developers out there like, hey, I'm making my foundation model.
Yeah.
And I'm sure it's very interesting. But a lot of what people want to do with LLMs can be accomplished by taking a foundation model and then augmenting it with, I have my own database. It's got sports statistics. And I'm going to use the LLM to understand language and then write, say, SQL queries, which is like a query language to extract summarized data from a database, right?
Mm-hmm.
Like take the average of this variable over these years for these type of players.
I see.
And
Now you're talking my language. I'm a big sports fan.
Okay,
so I
cool.
can understand what you're saying. Yeah.
So
it's
what's
good for
what's
fantasy
like
football.
a natural language question, you might have about sports, like
Sure. Well, okay. A recent one would be like, list the top 5 most winning NFL coaches of all time, right? Belichick just retired. Pete Carroll just retired. So that's been all over. Same with like Nick Saban just retiring, right?
Yeah.
So they've been talking about college legacy and NFL legacy. So, that's sort of a more general question, right? Now, the really crazy stats are in like baseball or the stuff they do in NFL, in the middle of the game, like probability for getting this first down at this point in the game, at this, at this down and distance, and they're doing this kind of live updates in game now, all these stats, and ESPN has alternate broadcasts on Monday Night Football where you could just get into the stats. You can turn it to another channel. That's all it is the analytics side. It's getting pretty crazy. Really across the board in sports.
So take the top 5 most winning coaches question, and if you just give it to the foundation model, it's going to think of that in terms of probabilities of some words occurring. And it might actually be right, is the crazy thing.
Yeah.
Because it may be trained on a bunch of people talking about this on the internet, and
it's like, that's an easy one.
The answers turn out to be true
Yeah.
on average. So you may not have a problem there just using the foundation model, but
Yeah.
If you want to get past that hurdle of it was only trained up to 2019,
Yeah.
You can use the foundation model that only knows about language up to 2019 to formulate an SQL query, and then have that query come back, with
give you a probability
answer from your database.
Interesting.
So it definitely seems like with a question like that, right? It's easy to pull up a set of numbers and say, hey, this coach had this many wins, he had this many MVP players come out of his thing. I think where it's like tricky and specifically related to Arkansas and football, it's like, if Bobby Petrino comes back to the University of Arkansas, will the people of Arkansas forgive him? Right. So when you ask a language model that's
Doesn't
a whole
know that
different
one.
question. That's
Yeah.
almost like
it's a psychological question, right?
Right. How do you get a bot to say, what's a psychological evaluation? What's a social? What's the history? So like, how does it answer questions like that aren't related, let's say, to facts?
I'd be interested to know that too, because it will give you an answer.
It will give.
It'll give you its best guess, right?
Maybe an analysis and say, well, he did good.
Yeah,
but
here's what happened.
The ethical side.
Yeah.
Right? So, what are your thoughts on that?
I think the fun thing is that you can kind of divide it into how it does and how it should, and then you can think about your opportunities as an app developer. Now that other people have produced foundation models and have made tools available for more targeted applications, right?
When you're talking about foundation models
Yeah.
for AI, like how many are out there? Hundreds? Are there key ones that everybody uses, or what's your guess on that? Or what is
It's a good question. I think there are tens, perhaps hundreds.
Because that's a huge task to put one of those things together, right? That's like...
Right.
Yeah.
And you'd have to put together a definition around what constitutes a foundation model.
Mm-hmm.
The practical answer is that there are very few which have performance that is dominant across these benchmarks or evaluations. So there'd be kind of a standard set of evaluations across all kinds of things like answering questions or even doing math problems. So this is one where LLMs don't do so well right now. There are these benchmarks, and the ones that are competitive for those benchmarks, maybe this is a bit of selection bias in terms of what I see like on LinkedIn, where I kind of get my LLM news, but it's going to be like, Google is competing with OpenAI, is competing with Amazon.
The big ones.
So there are independent players on this. I don't know enough about the LLM space in order to give the independent players their due.
Yeah. But they're probably out there.
Definitely.
Yeah, because it definitely, ChatGPT, its purpose is to essentially be something that's people to come to and to talk to, right? But I definitely feel like Amazon and some of these other ones, their goal is more to how do we use this to make our operations better, right? How do we use it to, it's less so I can write papers, right? And it's for a different purpose. So would there be a difference between, let's say, a company who's using it for their operations and let's say something like ChatGPT, or are they both kind of using that same fundamental model and then modifying it in a direction?
Great way to think about it. Yeah.
Well, there's also the consumer analytics model, right? How do we sell this person more stuff they want to buy? There's so many different applications, whether it's like you're saying, the operations aspect, you got this, different applications of it, right?
Yeah. So this is a fun place because we get to make a distinction I was starting to make in the first comment, which is there are, of course, branches of AI and machine learning which have nothing to do with language models. That's mostly what I work on. And so these would be questions like predict the probability that somebody is going to not pay back their loan or pay back their loan on the basis of these other variables. Make sure this is a fair model. This question doesn't even relate to the problem of I'm going to ask a question in natural language and I want some response, or I want to converse with.
It's almost in a way a more important and much more urgent topic. So let's talk about fintech. So that's what you're getting at, right? So if these models are out there that can predict, like, okay, based on this person's financial history, they're probably not going to be able to pay this loan back, or what's the chance they're going to default on their mortgage, right? Or what's the chance that this stock is not going to raise 20% by year end? Because now we have this issue where, especially retail traders like myself, we're trying to compete against, these huge firms who have these models, who can pretty much win the game before it's even been played. So talk to us about fintech and the applications you use it in, and then the broader kind of idea. To me, it's almost more important right now than the language side.
I think there's going to be a really interesting convergence between sort of the language side and all the other domains of machine learning. And I also want to introduce this term of decision optimization. So a lot of the time, a machine learning use case arises because you want to optimize a decision, right? So in lending, what a lender wants is they want their loan portfolio to have low risk of defaults, right?
Sure.
They want to have a high profitability and expectation, meaning they can make more interest income than the interest rate that they borrowed. That
ROI,
right?
Basic economics, sure.
Yeah, so there's the basic economic incentive, which you'll almost see this across use cases. It's so ubiquitous that you have a decision, and what do you want the decision to do? Well, we're a company, so we want to maximize profit. So this is almost ubiquitous, but it's interesting and more nuanced than that because there are these constraints that come up in decision optimizations. A huge one in fair lending is non-discrimination.
Sure, redlining and blockbusting and things like that.
Yeah. So optimize profit subject to not doing that, which is what I work on. So it's in the nuance of those constraints, specifically around fairness. And then the conceptual soundness of the model, which means the model needs to make sense.
Yeah.
Right?
So that's interesting because that's where the language part would come into that part. Because it's like, okay, we have this model to predict all this stuff and tell us who to loan money to. But we also have to tell the model, hey, while you're doing that, we can't do this and we can't do this, right?
These are people, right?
Yeah.
So we got to have some compassion, right?
Yeah.
So fairness is a modeling in of compassion to a robot. So what does that look like?
Oh, that's a good question.
Somebody's got to input to get
Yeah.
the right output, right? So
Yeah. Okay. So I'm going to come back to how do you operationalize fairness, and just say language models can have, as I like to call these, epistemologies of a language model. So the way that where I see a lot of opportunity for app developers, kind of you call it the retail traders of the software
Yeah.
world, is to take a foundation model, make an application of it that works really well for a specific thing. And the way that you would do it is you would give that bot different epistemologies or different ways of understanding the world. We talked earlier about having queries against a sports database, right?
Mm-hmm.
That would enable that particular bot to be better at the sports questions, and it's kind of custom tailored to that. So in this case, every one of those kind of very specific mathematical models we've built to work well in a financial institution is something that a language model can have as an epistemology. And then business stakeholders, especially those that do not want to speak the language of mathematics and the language of code,
Yeah.
should be able to interact with all of those ways of understanding the world, through the medium of language. That's where the language models come in. So there's a ton of risk in the sense that the language models can still profoundly get it wrong. But there's a ton of opportunity in the sense that when scientists really develop a careful way of understanding something, and you make that model available as a epistemology for a large language model, the large language model can make that something anybody can interact with. So if you've got a model of how jet engines work that describes the physics of it, and you make that accessible to a custom, call it a custom bot or agent, then you can have this little, nice way of interacting with that model, of getting to the knowledge that it represents without, needing to necessarily learn all the physics in depth. Maybe it can help teach you the physics.
So do you see kind of this point where everybody's AI will almost be able to have access to this place where it's all this integrated knowledge, right? So my AI model can interact with this database that interacts with other AIs that have already done that process? Is that kind of...
I'm
like a hive mind.
Because we're almost talking about like people are deploying in that direction, and they can only do so much, right? Because they don't have time to divert resources this way. But like, is there going to be a point where someone creates this thing that connects different AIs, allows them to like pull from each other?
That's the singularity, right?
I guess so.
That's when the AI takes over the world. No, I see what you're getting at. Essentially, he's saying, like, if there becomes one concentrated master AI, right? Database, epistemology,
library,
an epistemology of all epistemologies.
Of all of them. That's one
right. So
thing,
if I program
right?
my AI, it doesn't know how to do something, but it's really specialized over here. It can always report back to this one place, so that
it's a supercomputer.
Right,
there.
right.
Yeah, we're
talking
about
something that integrates
one
different
thing.
AI platforms.
Will that ever happen?
So there's a lot of speculation about the idea of superintelligence, which is not something that I spend a lot of time investigating.
Sure. You're in the weeds of fintech, right? I mean, that's...
Yeah, so I'm solving problems that are on a different time scale.
Yeah.
Right?
Yeah.
Of course, some people speculate the time scale for superintelligence is, very short.
Yeah.
Exponentially getting shorter as more AIs come out.
Well, when you have it in so many fields already, that's informing really high stakes decisions, whether it's what we're going to broadcast to an audience or who we're going to loan money to, or, what our portfolio is going to look like for long-term growth. I mean, it's already really informing, maybe ultimately that's a human decision, but it's really informing and guiding all these human decisions. Right. So, and that's where I think we're getting with you, is you're seeing it in a sort of a specific environment. Right. But it's informing the day-to-day business And fintech's one of those terms. Okay, we've been hearing more of the last 10 years. What is that? Who are these people? It's sort of the black box. I think to a lot of people that are skeptical of Wall Street, skeptical of large banks, they fintech is kind of like, that kind of freaks me out a little bit. So to Ben's question, when you have sort of a hive mind, whether it's specific to this field or not, I mean, what is your kind of opinion on that? Like that, are all of these fintech companies looking to the same resource as their epistemology? Do they all have their own models? How's that look in your world?
One way in which there are kind of common resources are when you have things like data consortiums, which exist for things like fraud data. So a bunch of banks might get together and say, hey, we're going to share what it looks like when fraud occurs in our credit card transactions, because every individual bank may only see a certain number of types of fraud, and the scam that hit this bank last week is going to hit the other one next week. Well, next time it might be your turn. So there's this sharing that goes on, and of course there's a lot of concern for privacy and for safety and how that sharing occurs. Probably maybe the biggest way that the sharing goes on in in the credit and lending application is through the credit bureaus. And in that sense, there are these widely relied upon credit scores, which we all know, like your FICO score, your Vantage score. So that's the closest thing.
Which they don't make any sense.
To what you're describing, which is like,
if you pay your truck off, your credit score goes down. You know what I'm saying? Like
too quickly.
You pay your car note off early, you get penalized. So that's a different conversation. But maybe these models will help change that and make it improve that outcome for people. But I think that's the concern that people have, is sort of, it's this mystery of, well, how is this going to impact my life at the end of the day? And a good example, I was recently talking to a friend who, she's an analyst at a big bank, and she, her background is really more crime analyst, data crime, right? So she essentially, her day job is at her computer, and the AI or the machine learning or whatever it is spitting stuff to her to say, hey, look at these transactions. We think this might be fraud. And we're talking like money laundering, high level fraud, like massive amounts of money. And then it's her decision to escalate stuff and decide, there's still that human element where she has to kind of go through there and figure out, okay, which one of these is money laundering? Which one of these is not? Is this actually fraud? So that human aspect is still really vital. And I think that's how I've been reassured by it all. As long as there's still the human element involved with analyzing the analysis, analyzing the data and ultimately making the decision, we should be all right. Right. I mean, that's in your experience, these data sets are being used by people, right? The machine's not making the decision ultimately.
So, I'll disagree with the idea that putting the ultimate decision in the hands of humans kind of ensures AI safety. But only a little bit.
Yeah.
In that,
I want to hear more about that. That's why you're here.
I think automating decisions can often be a safe and effective thing that can remove bias from a decision-making process. We especially see that because remember, I come from credit and I'm looking at discrimination.
Yeah.
And, this is something that can very easily come from a human being, as well as from biases embedded in a data set algorithm learns from. I think what works is regulatory scrutiny, whether it's from an actual, government regulator, which we're lucky to have in the case of lending, or whether it's from, just internal controls for safe and responsible AI. The way that I see it is actually developing models that can do amazing things is 10% of the problem. And what we call in fintech model risk management is 90%. It's really the lion's share. And that all starts with, what you optimize for, how you evaluate that you're doing a good job, right? And then it really requires a lot of trying to uncover things that you didn't think about before they happen, or recovering when they do happen, because you need to consider a lot of edge cases of how an algorithm can go wrong, how it can behave in counterintuitive ways.
The one time when when you hear the sound of hooves, it's actually zebras and not horses, right? Have you ever heard that? I guess Zach says that a lot. He's like, if you hear hooves and you're in North America, you should think horses, not zebras. But kind of like what you're talking about is those instances where it is a pack of wild zebras running around Arkansas, where the model says, hey, this looks like this.
That's an anomaly.
It's not actually what it is.
Yeah.
It just somehow someone arrived at the appearance of that same thing, but it was not, let's say, problematic.
That's a perfect point. So like, say that you have someone that's this isn't the case. This isn't actually an example that occurs in real life because of how people are treated in reality. But in a hypothetical world, say that someone had recently immigrated and their credit was scored according to the same guidelines as everybody else. This is very much a case of a horse and a zebra, where the sound of the hooves would be the measurable financial statistics you have about the person. And when you design a model, at least in the way we do it, there is a finite set of inputs and there's an output you're trying to predict. And so there's this concept of an omitted variable bias in statistics, right? Which is where you build this model, but there's actually one other really important factor that explains what's going on. In this case, it's the person's immigration status.
They just landed, yeah.
Yeah, and this relates to an issue of being what they call thin file, not having a lot of available credit data. And there are really cool companies working on that very problem of making credit accessible to people who have recently immigrated and are thin file.
Yeah.
Let's go ahead and take a few minutes break.
Alrighty, we're back from our short break. So in the break, we were talking about, so you are a data scientist, right? And we had some basic questions that we'd like you to outline for the guests and for us. Could you briefly just kind of explain what you do from your day to day, and then also give us a good definitions of AI and machine learning, and maybe some other relevant terms that you feel like apply to that field.
Okay, cool. So I'm going to try to start in the clouds of artificial intelligence. Go to the middle layer, kind of the pragmatic everyday layer, which is machine learning. And then when I describe my day-to-day tasks, a lot of it's going to be machine learning, right? So this is what I'm going to try to do. I'm going to try to go from the most abstract to the most practical. So artificial intelligence, as I see it, is the pursuit of emulating or surpassing human intelligence in the substrate or in the mechanism, computers, electrical circuits, right? Many people feel like that quest,
it's, natural. The natural approach to solving that is to emulate the biological brain and to do it in circuits. So there is maybe some feeling that deep learning, neural networks are a way forward towards that. And I say that because deep learning and neural networks are kind of the foundation of things like ChatGPT. There are other really important ideas that talk about how we get that neural network to have the right structure so it can learn how language works. And that's where transformers and the attention mechanism come in. The other thing about that is that neural networks are sort of a naive approximation to the biological brain. There's a very reductionist approach to it. And so the people that really want to take the biologically inspired route, or even if they're more hardcore, the biological emulation route, they are not the same folks necessarily that are working in machine learning or that are working on large language models even. I think Josh Tenenbaum is one researcher who's a great example of this biological route.
Hmm.
So that may be a wave of AI yet to come.
That's like the rich Elon Musks of the world creating Robbie the robot. And that's what you're talking about. You know, the biological. When I hear that, that's where my head goes. Like, you know,
It's like an automaton.
Yeah.
So it's the brain part
the brain part of that.
they're really interested in. So
Yeah.
it's the
You hear that neural link and neural network and stuff like that. Is that kind of what you're talking about?
neural is neuron.
Yeah.
Neurons being I'm not an expert on the biological brain, but
Yeah.
one of the fundamental building blocks of the brain. They're
Yeah.
connected by synapses.
And what's the next path? That's not the biological.
So let's step from biological to biologically inspired, right?
Mm.
And so that's the neural network. Once upon a time, neural networks were kind of a theoretical construct that you could do, but they didn't work especially well. They couldn't handle large volumes of data because we didn't have the right algorithms, and we certainly didn't have the amount of computing power that we have now. So for a long time, there was this Moore's law, which is not really a law because it's not really happening anymore. But there's this idea that, processing power had a very short doubling time. I can't remember exactly how long they said it would take for processing power to double. But computing processing power got cheaper and cheaper to get more and more of it. And then we learned some important things about how to distribute tasks across lots of machines.
Mm-hmm.
So now the nice neural network theoretical idea that we had before is something we can actually do. And that's where you start to see it be used in applications. And where it performed really well was on things that, say, emulated sensory data. So tasks like vision. And of course, most recently, what we've seen is breakthroughs in the understanding of natural language that have led to those consumer facing LLMs. And that's so I don't want to kind of misguide people about what the field of artificial intelligence means. It's not necessarily about emulating the brain. That's one idea about it. I think most generally, it's just that quest to emulate or surpass human intelligence in the substrate of a computer or a machine.
Processing powers can be far greater and far faster than our human capability. I mean, that's kind of the idea, right?
It could be that. It could be the advantage comes from better learning algorithm. So one really interesting field is like, I guess you'd call it behavioral economics. But kind of going back to this work of Daniel Kahneman and Amos Tversky, a lot of what they did was they took the behavior of statistical models, not machine learning models, but simple statistical models. And they compared that to human behavior and human decision making. And what they found is that humans make approximations about things relative to the statistical model, right? And those approximations are often quite biased, one way or another.
Yeah.
And
based on the context we have already, right? It's like each person's different. So,
yeah.
Yeah.
So the idea is that humans take shortcuts when they make predictions or in the way they reason about things.
Yeah.
And Kahneman had this wonderful idea of just saying the decisions that you make really fast, instantaneously, you're taking shortcuts, you're, making bigger assumptions in your approximation, and then the decisions you take slowly and you kind of apply careful logic and reasoning to, it's slower, but you can kind of perhaps get to a better sense of what you should be uncertain about and perhaps make a better decision. So this kind of work requires, of course, a lot of definition, right? So machine learning is when you take a particular measure of, this is how I want to say, the computer is performing as well or better than a human, say. It may not have anything to do with comparison to humans, depending on what you're doing. But you have a task. So we're getting a lot more concrete than just this general idea of AI. And to make it machine learning, what we need to be doing is learning from data how to do that task. So the paradigm shift is like this. Traditional programming, you make a bunch of logical statements. So if I'm a human being and I'm thinking through, I don't want to have to really do any reasoning about my financial decisions this year. What I want is I'm going to write a bunch of rules. And whenever something pops up that I could buy, I'm gonna run it through this rules algorithm. I'm gonna plug in everything about that thing, what it is, maybe some measure of its value, how much it costs, and this.
What's in my bank account?
What's in my the resources that I have. What are my ideas about my future earning potential, and it's gonna decide whether I buy the thing or not.
Yeah,
and so
or whether you go out to eat this tonight or not.
Right.
It's like, yeah.
So
don't go to the bar tonight. Yeah. Wait till next week. Right?
Yeah. So, that's a cool one too, because it's kind of like it's a binary decision. So the machine learning part focuses on a prediction. So rather than just directly saying, what decision do I want to make, we need to make it a prediction. So let's say we are writing this computer program. It's got a bunch of rules in it. So we're going to make a bunch of statements about if, this variable's in this range and you didn't go drinking last Wednesday and whatever, then, blah, blah, blah.
Practical living,
Say we're predicting if you'll feel well the next morning.
Yeah, right.
Say we're predicting that. You have a bunch of variables, say how much you drink, whether you exercise during that day,
right?
What you ate in that day.
What's your your nutrition habits, right?
Something like that, yeah. And so imagine, taking all that and trying to write by hand kind of a procedure. You just think of making if-else statements on paper.
Yeah.
That are going to arrive at a conclusion. The conclusion needs to be you either feel well the next day or you don't. So you could write that program by hand. And for a lot of problems, that gets hard.
Yeah. Especially for people that don't know what they're doing, right?
Even if you're the best programmer in the world, some things are just complex to describe. There's a complex relationship between the inputs or the outputs, or you're just not certain about what it should be. It might be a simple relationship, but it's just hard to figure out what it is. And how do you validate, if it's accurate? What's the error of your prediction? The error of your prediction is always going to be some measure of how far it is away from a ground truth. Okay, so enter data. When we wanted to measure error, we needed to record the ground truth on all these days, right? In the past, right? Where you might have gone out drinking and either you felt well or you didn't. So, if you had that past data, you wanted to measure whether your rules-based approach, your algorithm, was performing well, you would, see what percentage of the time your prediction was right on all the past data. That's called the accuracy of this classifier. The classifier decides yes or no. That's the kind of prediction it makes. Now, the only other step we need to introduce to turn this from kind of a classical programming problem into a machine learning problem is we're going to kind of flip the procedure. So rather than trying to come up with rules by hand, we're going to learn them from data. So we're going to take data. We're going to come up with a procedure that allows us to learn some model, a little mathematical model that takes the inputs, right? Everything that we know about, I don't know, what did we say? Your health habits.
Yeah, health, nutrition, right?
Importantly,
financial capability, right? How much disposable income do you have to buy something or go to the bar, go out to eat, or whatever the case may be, right?
Right.
Yeah.
So these are going to be your predictor variables, right? And then
Mhm.
you're going to have a thing you're trying to predict, which is whether you feel well or not the next morning.
Mhm.
So you're going to try to learn that relationship from the data. Now, this is where statisticians should get cranky because we've borrowed their problem and we've called it machine learning.
Interesting. Yeah.
But they've been doing this forever and have these approaches, linear regression. Well, in this case, it's logistic regression would be the most popular method for this binary classifier. And specifically what we described here is actually a sub-branch of machine learning called supervised learning, right? And it's supervised because we have this target, which is whether we felt well or not on past data, that's guiding our learning process.
I see.
And what we're learning is actually the function or the algorithm that maps the inputs to a good prediction.
Yeah.
Right?
I mean, that's this approach to me also applies to go back to the sports model, right? It's like predicting, and they do it in real time in the game. Like, what are the odds of converting this 4th and 4 at this point in the game under these weather conditions with this defense? It's like super interesting how accurate they can get, or how accurate at least we think they are.
Yeah. So if you have a lot of data, which they do,
Yeah, they do.
Of course, it takes some work to get it into the right format.
Yeah.
Because you need to somehow break all that down into the right set of features. Features is the term we use to describe the predictor variables. Sorry, there's about 100 different words for the same thing in machine learning, because machine learning is actually just this amalgamation of other fields that had already studied the problems, and then, let's,
we're
bring
taking
this
all these
together,
statistics
call it machine learning.
and analysis from the past. 50
Operations
years.
research is another one. Operations research was all about optimization for the most part, which is like, how do I pick the maximum or minimum something?
Yeah.
And so learning usually, I want to say always, but there's probably a gotcha in there. It usually boils down to an optimization problem. You're finding the model that is the most accurate, the most reasonable by some measure. So you're tweaking all these dials on your machine, and you're tweaking them in response to how wrong you are. And eventually you're coming up with the parameters that look the most reasonable given your data. And that's sort of the, analogy way of describing the learning process.
So that's where the human factor is so important, and that's where you come in. It's sort of like who are the people that are turning the dials and entering the info, doing the programming, the coding,
designing the outcome.
Yeah, design. Help. Yeah, that's essentially what you do, right? That's
setting up the problem. Yeah, and what's fun is there's this idea of so we want to learn parameters from the data. So importantly, what distinguished the machine learning approach to this problem from the classical programming approach was that I didn't have to set the knobs, say, but I did have to configure the learning process, and I did have to configure what we were optimizing for, what data we used, and I'm responsible for how this is applied in, what we applied in production, which is when there's some, software calling other software to get a decision or or a prediction. How it's applied, right? Because these mathematical models are really a reduction of the world. They're going to be things they don't account for, things they don't see or optimize for. So that's really, I think, the primary work of a data scientist.
Can you pull back the curtain a little bit on fintech, at least your experience in it?
Can I ask a quick question first? Because I don't want to go there, but just before we get. So from what I'm understanding is AI is, you're trying to build an intelligence, right? And you have a goal for that intelligence. And it has different components of processing, computation, data set, right? Machine learning is one of those components you can give an AI so that it can perform its task, but also have ways to check itself and then enhance itself, right?
Yeah. If AI is the quest for being as good or better than humans at a particular thing, machine learning is a means to do that. And machine learning proceeds by defining a narrow problem, right? A
Mhm.
narrow thing I want to be good at, coming up with a measure of how good I am at that, and then learning from data, you know, in order to get better at that. And that pretty closely matches, I think, the classic definition of machine learning, which will put some mathematical notation around that. Say there's a learning task at T, and you say you learn from data if you improve with respect to the task as you gain more data, something like that.
Yeah.
So
I mean,
an
that's
AI
what
without
Chat GPT is,
Right.
right? It's machine learning. I mean, that's
ChatGPT is machine learning, and in particular, deep learning, and then even more in particular, an application of transformer architecture
Hmm.
and attention, and probably other really specific and reinforcement learning with human feedback, right? Some really specific
and language
innovations
models, all kinds
and
of stuff.
in
Yeah.
that field, yeah.
Interesting.
In order to get to language models,
Mm.
right? Like language models as we know them required all these very specific innovations within machine learning to happen. And we just recently gotten to a really wonderful place with that.
Can you run through that list one more time of what all it takes to get there?
This is my naive understanding,
yeah.
right?
We just want to know the general kind of.
So the first kind of the primary arc, which doesn't even get to language really,
Mhm.
is to have machine learning, which we talked about, and then have this idea of deep learning. And deep learning is making neural networks. What's wonderful about those neural networks is we talked about defining the right inputs to the model so it can make a prediction. And neural networks can do representation learning, which is if I give you a set of inputs which is hard to interpret, like an image represented as data. So it's going to be, say, if you have ever done image editing, you think of a pixel. Right?
Yeah, that's where I was going with that.
And
Pixels,
the RGB values for each pixel.
That's crazy. So it's taking all that in, all that data.
Yeah.
And then, yeah.
So the magic is like, if I just took a simpler machine learning approach and I said, here are all the pixel values, predict whether this is a cat or not a cat, it's like, dude, this is incredibly complex. How am I going to learn a mapping a function between pixels and whether it's a cat?
Yeah.
They're so far removed from one another.
That's interesting.
So representation learning allows it to, in theory, assemble this kind of progressive hierarchy of ways of grouping and describing those pixels. So you have the idea of an edge, or you have the idea, oh, there's some kind of curve.
Some stripes.
You know what I mean?
Yeah.
So you build up from these atoms a way of describing high-level features. This is going to be a really poor way of describing the actuality of it, so it's more of an analogy. But say it learned the high-level features of I can recognize whether there's a head, whether it has pointy ears or not pointy ears. It's never going to be that way in practice.
Yeah.
But the idea is you can get to reasonable features like that from these very hard to parse atomic features in an image or in audio or in text.
That's amazing. I mean, it's amazing how fast it is. Just taking, Chat GPT as an example, or one of those, like you throw the picture in of anything you want, and it does all this. It knows which model it has to go to. Okay, picture, I got to decipher a photo. What is it? Take all and it gives you an answer in like a second.
Yeah, one of the kind of the bits of how that magic works is there are two different parts of the computation. There's learning and there's inference. And if we had to do learning from scratch every time someone asks a question, machine learning probably wouldn't go anywhere. Or we'd just have very simple machine learning models, because what goes on with the foundation language models, for instance, is they're trained for, I transparently don't know how long, but a very long time over a huge number of processors in order to learn to do what they do. But then querying it is dramatically faster than that.
Well, it's probably one of those things too. It's repetition and sort of librarying, right? It's like that archiving, because I ask it a question and it's like, oh, I've gotten this question 10,000 times from
That's called
other.
caching, like in internet
Yeah.
infrastructure.
Or this picture, I put the picture in.
Yeah.
It's like, oh yeah, I've seen this picture before. I
Like
know
in old
exactly what that
internet,
is.
you would have, if you wanted to load a page, it would have to reload the whole thing, even if you're on the same website.
Mhm.
But then they started integrating it where your cache allows you to, when you click to the next page, all the features that are the same stay. It only generates what's new. So that kind of seems like what you're talking about. Is like as it learns and gets these more answers, it has a cache of like readily available versus having to go through complex computation over and over again.
I'd be really speculating if I were to like try to guess, you know, what ChatGPT does behind the hood. I think something interesting to think about there is the traditional notion of caching is, say, I've done the computation 1+1 before. I went through it. It was really slow and hard, and I eventually got to the answer 2.
Yeah.
Of course, plug in some different numbers there, so it's actually hard. Say you took, you know, some very large number to the power of another really large number. It actually did take you some computation time.
Yeah.
But you stored the answer, so next time it's not going to take you as long. What's interesting is you can kind of broaden that to the idea of queries that aren't literally the same but are similar. You know, kind of a trivial example is like, who are the top 5 coaches in the NFL by you had a particular most winning?
Well, we were saying the most wins in history, but you could do like, you know, top 5 NFL coaches that have converted 4th and 1. And just something crazy, right? I mean, it would go find the answer.
So say there are, you know, a multitude of ways of asking that question, right? They're going to have high similarity to each other from a natural language processing point of view. So then, you know, what the difference is from the traditional caching approach is like, I know a stored answer to this, and I know this query is similar enough to this one in order to give this stored response. That's just speculating. That's an approach that you could do if you had a bunch of cached answers. Or it's going
to get the answer 85% there and then figure out the last 15%. If it's even then, right? Your cached answer could get you like pretty close to the right one.
That's a cool idea. Yeah.
I don't know.
I'd have to
throwing it out there.
Yeah. So that's what's fun. And that's where, again, like the opportunity for people is, you know, take the foundation model, build something on top of it, where you come up with a particular strategy like we are right now for answering questions in your domain, something you're passionate about.
Right.
So we were kind of like wanting to lead into fintech, right? So you explain kind of AI up in the cloud, machine learning as optimizing, right? So then you're leading down to kind of specific. You were saying what you do as a data scientist related to fintech. Can you lead us in that direction?
Yeah. So what I do is I try to formulate those machine learning problems the right way for the high risk application of credit risk modeling. I spend a lot of time developing a product for how you measure discrimination in credit risk models and in credit decisions. And that involves, you know, programming. It involves a lot of thinking, a lot of doing research on the approaches that other people have taken and trying to decide, you know, which ideas are you going to use as a starting point? How are you going to adopt them for this product, right? If you're looking between fields, you know, what are the assumptions in epidemiology that don't apply as well to credit risk? So, you know, if you're trying to come up with a way of doing something like causal modeling, that'll have been explored in a lot of different fields. How do we tell when one thing causes another to happen versus just having a statistical correlation, right? Trying to translate things down into your domain. Yeah. So taking research, taking the knowledge that we have about statistics, machine learning, making it work in this narrow domain, the data you have, the decision problems that you need to solve.
Yeah.
And for credit, this is going to be like, who do you approve and decline? What price do you give to a loan in terms of interest? There are other things, or I mean, there's tons of decisions you can apply machine learning to in a bank, right? So there's marketing optimization. Every department of the bank is going to have a litany of decisions that could be automated and can be optimized to get them better financial results, more fairness in those results. Yeah.
So one thing I'm definitely have noted and is that you're in a position where you have clients or banks or these people that are observing people doing stuff, right? The real humans going about with their lives, trying to then model it into answers for what they should do in making those decisions. As we get more saturated, especially as they become more practical tools, like a financial assistant for a person, right? They're using an AI model that helps them guide their decision making, and then you'll have this traditional group that is using AI to analyze and then make decisions about those people. Is that going to become increasingly complicated when I'm using an AI and making my decisions, and you're using an AI and making your decisions, and then trying to, because it seems like the AI could just be talking to each other and come up with
the best outcome.
The best outcome for both of you, right? And so in that instance, like, how do you have winners and losers? I don't know if that's the proper question, but it seems really
that's kind of where my head was going to.
Where you're almost running a pointless cycle of, rather than I have an AI who guides me and you an AI guides you, would you not naturally end at a point where there's an AI that tells you what to do and me what to do? And if we did that for long enough, would you even have a crowd that's making decisions over other people, right? Because wouldn't the AI kind of take care of us all equally? That's kind of, I guess, where...
Okay, so I think to ground this question in a theory, because it's a complicated question.
It is.
And depending on your theory, this would have a lot of bearing on how you feel about superintelligence, etc. And this is going to give me away as far as where I fall on that. Depending on your theory, there are going to be very different answers, ranging from AI will run the business. It will be what's called an autonomous organization, right? To I can't even think of what the most conservative perspective on that would be.
Can we go back to the 1920s or the Stone Age or something?
Throw the AI away. It's gonna, it's useless. Something like that.
Which humans, they've already crashed the stock market a couple of times. So maybe give the robots a shot. I don't know.
Right, because like with credit, credit is like it's like a gatekeeping thing, right? Where
it is.
There's someone who has access to the liquidity. Then there's this list of your history and what you qualify for, and you as a person just have to look at that and be like, well, I need to do better next time, right? But if you had an AI guiding your whole credit process, and someone's using the point of everybody will start having to have a perfect credit journey, right? Unless, of course, real things happen, disaster, whatnot.
Well, I think the
account for
piggybacking on that, right? The broader picture has to be for all these financial institutions is there's a cap on how much money they can actually loan. So that's it, right? It's like there's only so much money that they have access to at a certain rate from the Fed. So that all has to go into the data as well, right? And so that I think that's ultimately why decisions have to be made as to who gets credit and who doesn't. Because if there was an infinite pool of money, then we would all get credit, right? But they only have so much to go around. And so I'm sure that's a key part of your model as well, is sort of taking all this information in. How does it then decide who are the winners and the losers? And is that ultimately a human decision or not?
Especially if, let's say, people are starting to use AI to make their credit portfolio look flawless, right?
Mm-hmm.
They've used it to make their decisions. So 99% of people have a really good credit. Like, what are then the factors you would look for to give that money away or to loan it?
So I think this is going to answer the question appropriately.
It's a lot of questions in one. But
yeah.
It is a hard question. I had a hard time kind of like putting it in words.
If I can synthesize the question, I think the question is more or less, how do you govern the use of AI, the use of machine learning in a really highly sensitive application like credit, and the term winners and losers is really interesting, which I'm going to map in a simple way to like who gets access to reasonably priced credit
Yeah.
and who doesn't,
Yeah.
right? And that's a decision that influences people's lives. That's what makes it a sensitive application, right?
Mm-hmm.
So there's a theory, and I think people that work in really highly regulated areas of machine learning that don't afford them the ability to be super speculative about what they do and don't do would share this, which is that machine learning is incredibly powerful, but incredibly dumb, right? It's super smart and it's super dumb. in that, think of it as being way better at you at solving a particular kind of math problem, but completely lacking common sense. That is not why you shouldn't use machine learning. We sell machine learning. We think it's good for people. I built my career on that premise that machine learning can improve
It's like a calculator.
a business.
Yeah.
But where it is blind, that's where human supervision and even better, organized supervision, regulatory supervision is necessary.
Yeah.
Yeah. Because machine learning, like when we talked about its definition, right? We talked about solving this really narrow math problem that we had defined. That doesn't resemble the common sense and wisdom of human intelligence. We don't know how to operationalize the common sense and intelligence of, humans, especially of like an organized collective of humans that gets together and thinks about what's important, what are reasonable guidelines. Can't emulate that in a machine learning problem. So at the moment, we'd say it's not a machine learning problem. It is a problem of, ethics, of philosophy, and then of getting really practical about, how you make sure things play out fairly.
Yeah. And it's those ethics and philosophy questions that it can't really solve. It could give you all the data you need to make an informed decision, right? But ultimately, someone else is deciding who gets this car loan and who doesn't.
Yeah, it can be
Right.
it can be useful, right? So this goes back to like statistics is not economics, right? Economists use statistical models to answer economic questions, but economists pose economic questions and then, get answers by using this tool. So I still think AI as we know it is just a tool. Now, remember the way it's defined is we're trying to get up to or surpass human intelligence.
Yeah.
So there's this competing idea that, people are looking for this very general AI, for, general artificial intelligence, and maybe emulating that common sense and wisdom that we had talked about even. But either because we're not there or because we'll never be there, because that's fundamentally not what AI is, even if that's what we'd like it to be, humans guide the process of decision making.
Yeah.
Maybe not individual decisions, but how will a machine learning model be applied to make a decision, right? And humans, very importantly, ask scientific questions about the world, which can be answered through mathematical models.
So to get to the lending aspect, practical question. So you have a set of inputs, right? Here's their annual income, here's their employment history, here's their credit score, here's their net worth, here's their assets, here's their available money. You put all that into the model, and then it spits out what? Does it give you like a probability of default? Does things like that? Can you tell us the kinds of information it outputs? Like what sort of things does it tell you?
Yeah, that's the most common output in a model that's used to assess a consumer's credit risk, or a business's credit risk for that matter, is the probability that they will not pay something back.
I see.
The reason for predicting that, of course, is the bank is trying to forecast its losses.
Yeah.
If it makes this money available.
If it can pay its loans back, right?
Yeah.
Ultimately, they have a creditor as well, right? So
Let's take 5.
What's that?
Let's take 5.
Yeah, sure. We'll take a quick break and come back in a second.
We're back from our break. We kind of
a few minutes and toss some ideas around. So kind of where we're going to head is we're going to let Johnny take it off with questions.
Well, I think we've been in the details of fintech in regards to really lending, right? Whether that's credit card lending, just mortgage lending, bank lending, and where my head goes with all this is sort of the mortgage lending crisis really in '08, right, caused a lot of larger market issues across the financial world. And so when we talk about fintech, my head goes to Wall Street and sort of, okay, how are the hedge funds using it? How are the BlackRocks and the Citadels of the world using it? And I think a lot of the retail trading world thinks like I do, because I'm a retail trader. I'm sure a lot of people out there are, but it's sort of you have that gatekeeping kind of idea. In some ways, this machine learning, right, is going to help prevent what happened in '08. These high risk loans, too many out there, can't be paid back. Maybe probability models now will prevent that from ever occurring again. So in some way, and we'll see, it could create market stability because we have these, algorithms telling us don't lend this money. That's a bad idea, right? But the other side of that question is sort of how does machine learning inform the larger financial picture in regards to this idea of retail trading? Like how, is it still a fair playing field? How can retail traders trade in a free market against, in some cases against, in some cases with, right, hedge funds, when they don't have the same tools? And this idea of winners and losers, you see this all the time. Retail often tries to create short squeezes, and that's a big part of retail trading. And maybe that's, not the best way to do necessarily investing. And I think if that's your only way of investing, it's not a good idea, right? But sometimes you're trying to hit the lottery on a short squeeze, and sometimes it's a principled bet, right? Where Wall Street decides, okay, we're going to choose the winners and losers, and we're going to take down AMC and bankrupt them, right? And retail says, no, we like AMC and we believe in them long term, and we're going to, invest in them. And so this idea of winners and losers, what is your thoughts on the broader financial world when it comes to machine learning?
The broader financial world being
Wall Street, hedge funds, the bigger players, and I'm sure the Fed is using it now too. But what are your thoughts on how that can inform, winners and losers? I guess
something that was really interesting, like you said, with this idea that machine learning, I'm going to summarize the value of machine learning as better prediction, would have avoided the crisis in 2008.
Yeah.
And I want to
would it have
counter that.
Yeah, sure.
So what if we had perfectly reasonable predictions? We just misuse them. Yeah. So there's this thing about tranches, aggregating risks. Mm-hmm. These are well-known statistical concepts. The idea that if I have a whole portfolio of, say, people insured, if it's insurance, equities, a portfolio of loans, there's this concept that's common to all of them through statistics, which is that my risk changes as I get more and more and more of them. There's smaller variation in the outcomes relative to the amount that I have invested, right? Which is cool. And it allows us, as long as those, by the way, there's this assumption, the risks are independent. So a lot of people speculate part of the 2008 crisis really was a modeling failure. And it had to do with that assumption that these mortgage risks are independent. So there was a systematic under evaluation of the worst case scenario. But I think a different perspective on it is that this was back to kind of those regulatory questions, the philosophy of ethics. How do we govern AI? And
that's a big sort of mystery right now. I don't, the government hasn't figured that out, and that's part of the reason you see a lot of retail traders constantly complaining calling representatives, calling the SEC, saying, look, it's not fair. This is not fair trading anymore. The markets are being manipulated, and it's not a fair playing field. And maybe that will change if the regulatory bodies put things in place that they haven't yet. I don't know. I mean, maybe that's the fix.
Interesting thing about the stock market specifically is that it is an economic model because it's based on human beings going around, the consumer, right, buying the product from the company, the officers of the company doing the right thing, running a good business, right? That all factors in.
Theoretically, yes, but like AMC is a good example because while they've had quarterly earnings reports that have been good the last 2 years, they have, they have debt that they've been trying to pay down. They've done stock splits to do that, which that's a liquidity issue. But at the same time, the price continues to go down, even though ticket sales are back to post-COVID, kind of pre-COVID numbers. So yeah, in theory, what you're saying, yes, the consumer drives markets, but at the same time, that's not always the outcomes we're seeing.
And it affects markets. If the stock markets do well, then the economy, business does well. But then at the end of the day, people, companies such as BlackRock, they're operating in the stock market off the bottom line. So they're not always calculating their moves to be like, yeah, how does this, obviously if the economy's good, they do better, right? But the agendas of all the companies investing is just profit, right?
Yeah.
So you've got this thing that affects people's lives based on people's lives, but then you're making decisions based on profit. And kind of, I think where we're going is like, if a big player uses AI to always make sure they win or to dictate their moves, then you leave everybody else in this guessing game of it's not so much about chance anymore. It's more, do I know what they were going to do? Because if you got a big enough person in crypto, it's called a whale, but a whale can bring the price up or down. Just on a flight of fancy, they say, I'm going to sell 10 million Bitcoin or whatever.
The whales are the hedge funds.
Right. And so they almost create that winner or loser thing.
That's right.
You can't really have insider trading. It's legal, right, by the SEC of like saying, hey, my company's going to sell thousands of shares tomorrow. Yeah. Hey, cousin Jamie, whatever, sell all your stuff tonight because it's going to go drop it, right? So then you're looking at people, everybody using AI, like is these AIs communicating with each other? Is that insider trading, right? Because it's a predictive modeling, creating a script versus the traditional stock market's whimsical.
Yeah, the model is the insider now, right? That's
right.
Telling you what to do.
So what are your thoughts on that? Like, what do you?
I want to learn more about your picture where you have these AIs talking to each other. So I'm thinking, I'm thinking an AI in the sense of like a language agent, because they said they were talking to each other. That may not have been what you meant.
Not communicating with each other, saying, okay, so let's say me and you both use this app, right? This app that we downloaded off this thing that we put our financial information, it's got access to the stock market, and it's going to try to give us some informed decisions. That's kind of our game plan, right? My game plan as an individual.
What you should invest in.
Right? What are the numbers? How should I move my stocks around?
Is that what you call like a robo trader?
Kinda, because I mean, if you were
a robo advisor,
basically,
someone who's capable of giving you better outputs than a financial advisor is, right? Because it's taken all this data, machine learning, right, and then tuning itself to your portfolio. So there's me as an individual trader, you as an individual trader, all playing this game, and AI is trying to predict what the stock market's going to do. But when you have big players, when they do something, it affects the whole market. When they just make a decision, they're not as much gambling as much as saying, we're going to move our money here, or we're going to move our money out, right? And if I move my money out, that company goes tanks, right? And so it almost seems like smaller traders would want to develop AIs that can kind of predict what the bigger traders' AI is going to tell them to do, right? So it almost moves the game out of stocks. The numbers takes it into account, but then it says, what is that guy's AI going to do? You kind of go, does that make sense?
That's interesting. It's kind of a theoretical conversation that could already be occurring, but probably will in the future occur, right? It's like, I don't know. I guess that's a future question. Do you feel like, as more machine learning models become available to consumers, I mean, I imagine you probably hit the nail on the head. Like there's going to be some type of app you can download or something that's going to be your financial advisor and tell you what to invest in, right? And then the hedge fund world has theirs, and retail trading has theirs.
The war of AI of like,
Yeah, it's like that.
guess what people are going to do so we can put our money here so it goes exponential.
But there's this effect that's going on where once somebody has an idea, there's a term for this, and people that deal with equities, they call it some letter. I think they call it alpha. They call it alpha. This isn't my world.
Well, this is kind of always, getting back to this idea of being in a post-truth world. Sort of like, the markets in the old world, the markets were really driven by consumers more. Like you were saying, if this company does well, their stock goes up, everybody's happy, right? Whereas now we're kind of in this sort of, well, is the market true or not? And I'm sitting at home looking at my portfolio and a stock I know is worth way more than it is.
Yeah.
Retail traders know there's manipulation happening every day. And so that's where the markets are now in this kind of post-truth. And where does it go from here?
It's less about how the stock market should perform and more about this person's decision to pull out or to keep
the way it's being more manipulated on a daily basis, right?
So I want to go to the case of mass adoption of the robo-advisor.
Yeah.
But this happens especially if there's a single robo-advisor that's adopted by a large number of people, right? So as I understand it, alpha is lost when that investment hypothesis becomes mainstream. But they say it's priced into,
yeah,
that idea is accounted for. And so I don't know, maybe it's a bit of hope for retail investors. So this is not financial advice.
Yeah,
this is
we like hope for retail. We need all the hope we can get. Yeah.
But something that could be explored. And I saw this in particular on a platform called Quantopian, which I was interested in because it's a way to learn the basic mathematics and approaches to algorithmic trading. And one of the people involved with it was also very involved with Bayesian modeling, and I'm very interested in this particular.
What is that?
Technology. It's a way of incorporating your prior beliefs into a prediction.
I see.
So say I've only got 5 data points about something, but I have also got an opinion. I want to merge those.
Gotcha.
One way or another.
Yeah, that's called what now?
Bayesian modeling.
Bayesian.
Yeah.
That's someone's name? Or is it?
It is actually. Okay. It comes back to Bayes. I don't want to say his first name in case I get it wrong.
Okay.
But he was a minister. And came up with Bayes' theorem, which is just a simple rule in probability theory. But what it represents is a way to update your beliefs given that you observe some data. So that's what we call Bayesian updating, which is a layer on top of Bayes' rule. Bayes' rule is just a simple finding within 10 minutes of learning the basic definitions for probability theory. If you were looking for it, you could probably figure out Bayes' rule.
I see. Yeah. So how does that apply to this, you think? I mean, that's,
what I was going to say is not about Bayesian modeling. It's about the idea of having a counter consensus belief. And I'll speak to something I know a lot more about, which is startups. So Sam Altman said that, paraphrasing, good startup ideas sound bad, but are good. And I think you could say the same. I mean, a startup is an investment hypothesis, more or less. You're investing your time, you're getting other people to invest money. If you're the founder, you're raising, but same basic idea.
And eventually you're going to have an IPO.
This is going to be a good equity because these consumers want this that's not met by the existing products because I believe this is true at bottom. You believe that? Well, if people feel that way, but that's true, that's not priced into the market. That's not an existing company. And, so maybe there are people that there are entities, not people, that are so large they can move the market by taking an action. So it's less an act of prediction and making a decision And it's more an act of taking an action that changes what everybody's prediction should be, right?
Yep, that's exactly kind of where my question earlier was getting to. It's like when you get to that point, your game becomes more about learning the big corporation who's going to make that decision and when they're going to make that decision, and less about what the game and what the rules are, what the probability is. Kind of makes it an artificial market, right? And that's safer, but at the same time, you remove the point of the game. Usually, the whole time is that let's fund companies that are doing well to grow up, and then we all make money, right? Or we made a bad decision, the person made a bad decision, everything tanks, right? So
You're right.
when chance goes out, people that tank, they can't say, "Man, I made a good run of it. We just failed." Right? It becomes you failed because we didn't want you to succeed, right? Or it's more of like a selection thing, even if it's not conscious selection. It just becomes this company says it's not good for our bottom line. Whether it's a good prediction or not, they're still going to pull their money out, right? And then it becomes true, right? That makes sense.
Yeah. So we could think of those movements. If all that's true, if that assumption is true, that you've got these big players, they're going to make moves. Those moves aren't random. Importantly, they're maybe predictable. So this gives you some hope for what you're trying to do, right? And we can now have beliefs about what they're going to do and when. And that can affect the trading strategy and the profitability of that trading strategy. And, we can disagree with each other. And so we can think of those big movements as all part of what we predict the future movements of all these equities are going to be.
Yeah.
Right. So it ought to be, if that's indeed the case, it ought to be part of how we develop investment strategies, right? That are, say those strategies are going to run themselves, right? Rather than being discretionary trades. You would want to, now this prediction problem is hard because these are like, if you think of it as a graph over time and you have some number in that graph, you have a big movement. Say that's the position of a given hedge fund in a certain equity. All of a sudden it drops. So it's hard to predict. Like if you just had that, what we call a time series, which is just like a single thing sampled over time, over and over, you just what stock data looks like. Or if you just had that, you want to predict, well, let's assume they're going to dump a certain equity. When are they going to dump it? Hard problem.
Those are conference room conversations.
They are
with the doors closed and nobody on the outside.
Well, I've thought about this. Getting back to your idea of robo analyst, right? If part of the issue here is that the hedge fund in X stock that holds millions of shares, they make a single point decision with what to do with that stock, whereas retail is autonomous, disparate. Everyone is on, some may be on the same page, but others aren't. And retail is harder to predict who's going to do what. Business idea for somebody a lot smarter than me. If there was a single point of trade for retail traders, for example, we're all going to go in together collectively with our millions of shares and do one single point of trade, right? There's an opportunity there. That's how
the bigger companies.
Yes, to combat the hedge funds, right? If there's a single point of trade for retail, then you could maybe get the stock that you want to squeeze. You see what I'm saying? Because then your AI model is combating the Citadel and BlackRock's of the world's model through a single point. Now, the way to do that would be through some type of technology, machine learning company. And who that is, I don't know. But I mean, in theory, I think that could work. Maybe it's far-fetched. But I mean, if you think about it that way, think of your inputs as the shares held by all of retail. Your outputs are these informed decisions. I mean, what do you think about that theoretical idea?
So it's like the chat GPT for traders.
Yeah.
Right? Everybody's got their bot, but the issue being there is like when you feed information to chat GPT, it takes that in and then it uses that with other users.
You'd have to
Everybody's got
opt
their
in.
own trade bot. You almost have to program ignorance so that it's telling me advice. It's ignorant of the advice it's giving you.
I think it's
it's
a great startup idea, in my opinion, for someone.
Right.
I don't know how you go about it, but I mean, is that with your background and thinking about startups and also machine learning. Is that an opportunity for someone to create this company or a single point of trade for retail traders? I mean, do you see what I'm saying?
I couldn't tell you
Yeah.
because it's just not something like there's this idea of a circle of competence, right?
Yeah.
And equities is like really gets outside of my circle of competence, which
Yeah.
I don't mind saying, to anyone, my personal, trading strategy, this is not financial advice, is to take the average of the market, get a nice mutual fund and
Yeah.
sit on it because I don't know.
I think
I'm
most
not
of us do
spending
that.
all my time coming up with
Most of us do that, but then we go to the casino, right? Which is you got these plays that you think might happen. And the issue now is we feel like the possibility of them happening has become entirely mitigated because of these data models that are pushing us down constantly.
Right, because the bigger companies, let's say definitely BlackRock, when they make a decision about financing, they're not making it always from the perspective of this profit, right? Because I feel like they have access to a limited amount of capital, right? So typically their decisions are made more on what they're trying to accomplish socioeconomically, not just how do we make another
Their
million,
larger
right?
picture. Yeah.
So when they decide it's that they're making a move based on what they think is good for the whole world or to push whatever their agenda is, there's definitely a shift out of just numbers and then what do they want to see put in.
Yeah. I mean, I think the reason we've gone down this kind of tangent is because so much of what we've talked about with you, my head goes to places that's like, machine learning and all this stuff is going to completely change, and I think already is changing the financial world. And the broader financial world to me is the market and what are the markets doing and who's controlling them ultimately, the whales, and that who that regulatory body's in place. But the last several years with sort of this huge boom in retail trading, really through what has been called the meme stocks. You had the huge GameStop squeeze and several others that have been placed. Crypto being one of them. Various cryptos people have made lots of money on, right? And it's sort of like, well, while the risk may be taken out of the market with these machine learning AIs or whatever they are, it's also, while the risk is being taken out, it's also eliminating the opportunity for retail traders to make a squeeze play, for example, because now the squeeze is not going to happen, right? It's like, or
it's the idea that that potential move has been predicted, like
yes,
it's
being predicted. The outcome's been predicted, and so you can call it manipulation if you want, manipulation of markets, but really it's just like highly informed machine learning is telling, and probably even making the trades in some instances. I'm sure they have a button they push. It's like, keep this stock at this point for XYZ.
So this would be called an automated trading.
So that's what's happening. Yeah.
This is, I think in general, I like this idea, maybe not just applied to trading, but applied to things, which is let's come up with a algorithm for making a decision.
Yeah.
And let's use data to make our best guess about the predictions that inform that decision. How likely is this outcome given that I do this, more or less?
Mm-hmm.
That outcome should be what I care about.
Yeah.
Given that I study 10 hours, what's the probability I make A?
They're risk management, right? They're decreasing the probability of that possible outcome and then telling the software to automate this trade to prevent it.
Yeah, the outcome in this case being, given this suite of strategies, I might try space of strategies, things infinite, right? What's the expected profitability of that over a given timeline? And not just expected, meaning the average case, there's a whole distribution of outcomes.
Yeah.
It's a random or stochastic process, meaning something could happen, and then based on that happening, the branches of possible realities just grow multiplicatively every moment, right? You think of like all the parallel universes that could happen based on the next time step. So I think of a random process, right? The next step in the future is the most predictable one. So think about the value of an equity or anything, value of a bond, and random things are moving it, but they're only going to move it a little bit in the next 5 minutes.
Yeah.
Or whatever the smallest discrete time scale over which the time step over which the price of an equity is changed, updated.
Yeah.
That's going to have the smallest variation in outcomes. By the time you project out a year, it could be anywhere,
Yeah.
It's very wide,
Yeah.
the possible outcomes.
That's amazing, because what I was just thinking about is how these models and machine learning implementations and automated trading, how they're impacting the analytical side of markets, right? Because used to, and in some cases it still occurs, there used to be ways you could look at a stock over a period of days or weeks or months and figure out, there's these, shorthand, like the cup and handle. There's things you could look at to say, okay, this is what's about to happen.
This is what they call signals. Is that
signals, right? Like, we think this is going to happen because it's happened with other stocks, and this is what's going to happen next. But what the problem now is that all those old models are being auto trading and robo trading or whatever, machine learning trading is like erasing the old models. Now we have to look, what are the new models? Are there even new models? We don't know. But because there's been several times in the past couple of years, based on old data, we thought a stock was going to do XYZ. Yeah, didn't happen.
So suppose you're thinking that way. Well, suppose there's a broad consensus amongst lots of people that the AI models are fundamentally better because they're excited about AI.
Yeah.
A counter consensus idea, if I were very interested in finding my own investing strategy, which I'm not, I'm going to continue taking the average of the market, right?
Yeah.
And being lazy and focusing on
It's
other
a safe way to grow. Yeah.
But if I were the type to want to be counter consensus, what I might do is I think everybody's hot on AI. So I'm going to try these really simple ideas. I'm going to maybe go back to something
The old way.
The old way, right? If there's changing opinion about the old way, I might look at that. I, in general, want to look where other people's beliefs are concentrated. And I'm going to think about, is that reasonable? And I'm going to have thought, not just pure predictive power, but thought behind strategy. And what I saw in Quantopia, and this is very anecdotal, but I just saw a bit of a trend, which was that people would come up with these simple strategies. And that was more or less a good way to go, in the sense that empirically, they'd come up high on the leaderboards. And it wouldn't be this idea of the most complicated algorithm with the most inputs, trained with the most parameters wins the day. Because there's this idea of a bias in statistics, and a counter consensus idea has a bias relative to what other people are doing. Now, very importantly, it's not biased relative to the truth, because then it'll be wrong, you'll lose money, etc. But the idea is you need to believe something other people don't believe if you're going to be this tight to engage in that kind of thing. You need to believe other people are overvaluing or undervaluing something. And it might help if there's just some human intelligence involved in that has some reasons why that's true. And then, the math is a tool, right? The math is a tool. So it goes back to that. Let's ask a scientific question about the world, carefully guide it, and use mathematical optimization as a tool to help us get there. And I'd be really curious to hear from somebody that's more expert in retail trading, whether they think that.
Yeah, we want to get somebody on.
Better than
maybe you connect us to someone that can come on that's deeper in the roots of this world, because it's a huge part of discourse right now. It's I think the reason, obviously, the GameStop phenomenon kind of pushed a lot of new retail traders into the market, and that's part of what's happened. Is now the market's just flooded with retail, and I think in some ways it freaked out the hedge funds a little bit. They're sort of like, how the hell did this happen? We can't let this happen again. And you've seen a few like smaller little squeezes happen, but nothing like what happened with GameStop. There was Volkswagen years ago where this happened, but it was another set of circumstances. But I think a lot of it has been risk mitigation. What can we do? How can we use these tools to stabilize not only our portfolios and grow our ROI, but also prevent any type of market crash from rippling into other things?
Do you think crashes are really preventable? You mentioned that this idea that machine learning would somehow get rid of crashes, which up until
it depends
now,
on the type of
fact of the market.
Depends on the type of
market has crashes up until
yeah.
now, and they're stochastic. You don't know when they're going to happen. That's another part of crash. Other people more expert.
Depends on the type of crash, right? The crash in the 20s because there's a bank run, and you had retail people who got all their money in the banks saying, "We need to get our money out," right? And so that was part of it. And then the '08 one was obviously the bad loans, which put a lot of major financial institutions in harm's way, bankrupting some, right? And that was a ripple into the whole thing. I mean, I guess now I feel like it's become more stabilized because so much money is in the hands of these whales. The only way a crash would happen, I think, there's other factors that would cause it, whether that's, global war or something else. But I think a major market crash now, they are mitigating that with these models. And so, because, you could cause some serious issues with one or two big squeezes.
So is the idea that if back in 2008, more of the total share of equities were concentrated amongst hedge funds or whales of the kind of equity pool,
no, I think
the crash would have been.
No, I think the models would have prevented lending, because that was the mortgage crisis caused the crash.
Oh, so this goes back to the very start of this.
Yeah, it gets back to the credit side,
where there's disagreement amongst very smart people.
Yeah,
and it's maybe the story is that it's both. So I think we could look,
because it was the mortgage defaults caused the crash. There all these loans occurred.
Yes,
that should not have to people who probably couldn't pay them back. So your probability models would have told the banks at that point, which I'm sure they had them.
What you really want to look at is, were the probability models wrong?
Yeah.
Or
did the banks just get crazy?
All models are wrong. Or were they misused? Right.
In the instance of the 2008 crash, there was excess lending, but part of it was the inflation game in the housing market, right? That if I do this, I hold it, I do these things where the price of this piece of property just keeps going up because I'm playing this game, when the real value of it is way much lower. And so you cap out where the bubble bursts, where homes double its value, but only because we've been playing this trading game to continue to increase it. Of course, there's the loan side of it, but there's also that we pump the real estate market so that it rises and rises, and then it dumps. And
it dumped because people defaulted. You had just massive default on these bad loans.
There's a positive feedback cycle there, which is very interesting, which is if you have a variable rate APR, right, something that can change.
Yeah.
Well, suppose a bank has a bunch of defaults, and it's setting this variable APR so it can more or less cover its risks.
Yeah.
Right. What might happen in that case is a bunch of people default, so other people's interest rate goes up. So then they default. So then a bunch of other people's interest
somebody else
rate
gets to
goes
foot
up.
the bill.
So then they default.
Yeah.
So this effort, if this is a gross oversimplification.
No, I know what you're saying.
Yeah. But suppose that the interest rate were supposed to be a control on loss, and it kept going up as they experienced losses. And then other people defaulted as a consequence of changing it. So it's this positive feedback cycle. What we try to do when you regulate sort of an economic system is you want to get those nasty feedback loops out of there. Because usually when there's some very erratic behavior in a system like a crash, you find some kind of exponential behavior that comes from feedback.
I see. Yeah.
So if we're talking, we probably need to
take a little break.
Yep.
And then we'll be back and probably wrap it up. Be right back.
Alrighty, and we are back. One thing we were talking about it earlier, and I just wanted to mention it. You're talking about like, you know, what was the platform you said?
Quantopian.
This idea of people just using simpler decision-making things. I saw this randomly. I saw this meme the other day that was saying, you know, a group of students did a college competition to program an AI tool that could play poker, right? And so all these guys were going to play poker against each other. Everybody else was creating these complex coding decisions, right? Of like, if I've got these cards, this much chips, what do I do? You know, the guy that won, all he did is if blank all in, he won just because all his code did was all in every time, and he just slowly won the tournament.
Like if I have certain cards or not, or whatever.
Right. So he didn't take any of it into account. He just said all in every time.
Wow.
He ended up winning, and someone was like, everybody else was coding a bot. He was playing poker. Right.
He's got the hedge funds algorithm.
Right. And so kind of leading back into like the market, you'd never know when someone's beliefs or what their goal is different. Like for instance, in the stock, I mean, what if someone's goal is to crash the market, right? And so they're using their AI and their decisions to negatively affect the market.
Could have war on a financial scale.
Right. Or you just have someone who says, I want to be an agent of chaos.
Mm-hmm.
One day I sell, literally just randomize the decision making, right?
Mm-hmm.
And that also will affect the market.
Turns into a James Bond movie pretty quick.
Yeah.
If it's in the wrong hands.
Exactly. What are your thoughts on that? Like, do you think that maybe isn't out for what we were talking about, this idea of there being this chokehold on the stock market where it's no longer fair, but then you kind of have to bring back in this human element of we're all on different decision trains, right? And we have different agendas. You can't account for
stability has to be the ultimate goal, right?
You can't account for a sociopath. You can never in any type of we never think like there's actually a bad person out there who is making bad decisions. We always think of like everybody's kind of out for the good of themselves and the people around them.
Is there a question?
We're getting into philosophy now.
Maybe that was a little more of a tangent. But I didn't know we wanted to kind of like pivot and go towards AI.
Well, I guess before you get to art, I mean, to reframe the question, like when you look at machine learning, it could possibly be used for nefarious reasons.
Oh yeah.
Right.
Absolutely.
So tell us about how you thought about that, like how it could be used in cyber war or financial war. I mean, what are the risk factors there?
That's really interesting. What I usually think about is people with the best intentions trying to make these decisions fairly, trying to make this whole process work well, and just avoiding the risks in we got it wrong because we didn't think of that. That's model risk management.
Yeah.
So that's what I'm used to thinking about. Now,
not necessarily the nefarious actors.
The nefarious actors is fascinating. I mean, how tough is that?
The James Bond villain.
Early on, like when GPT was getting good, I thought a little bit about, based on what we'd seen from the influence campaign during the election, how can this be used to that end? So
was a lot of that machine learning driven?
No, it was these individuals just creating content.
Yeah,
it was content creators with a purpose to influence the election.
Yeah, it's a lot of what we talk about here, and we talked about in our last episode is how, you have the overconsumption and oversaturation of media.
Yeah,
all put through the context of point of view, and how do you analyze it and wade through what's real and what's not, what's fake and what's not, right? And that's where we're transitioning kind of into that. How does machine learning affect the ability of us to detect what is real and what's not, right?
For one thing, what I think they'd call in cybersecurity the attack surface, right? Of social media, of our email accounts, of our phones, all the places we receive information is huge. And we'll call it the offensive capability of generative AI, to me, seems vast. The ability to generate propaganda content easily is...
Or fake data.
fake
to
data.
manipulate markets, for example? Or, I mean, there's a litany of ways it could be used, right?
Suppose you are attacking an AI model, right? You automatically probe it to try to find vulnerabilities, right? Hopefully, companies are engaged enough with doing their internal testing. We call it red teaming, to secure some of those vulnerabilities, because if it's a very important application, other people are going to be going after it, trying to find vulnerabilities in this model.
Oh, yeah.
And trying to exploit it.
I'm sure there's already people trying to send all our drones back here to bomb us, right? That's like, you think it goes, your thoughts go to Terminator pretty quick. It's like, how could this all get off the rails?
Yeah, cyber and propaganda together seem to be a big part of what I've seen it called the information war, and I like the term, and I think it's very relevant, of course, to the title of this podcast, Post-Truth.
Yeah.
Right.
All of this is
propaganda is deliberate manipulation of people's opinions to achieve some goal, right? And it's usually done on relatively large scale, like influence public opinion.
Yeah.
And usually it's also, especially with social media, I think the reason it's so captivating is because typically it has to do with something we see or hearing someone say, right? It's not always just like, oh, I sat down and read a medical journal the other day and they deceived me, right, with bad information.
Yeah.
It seems like it's very sensational too, of like, specifically with the war on Ukraine or the war, like what the conflict in Israel, you're seeing clips of stuff of like a child getting blown up or a building getting taken down. And then you see that in the news, you see the sensation. And then I think it was CNN that showed this battle that was happening somewhere in Syria. But then someone came out and was like, we analyzed this footage. It was a video game. They were launching stuff at each other in the video game. They edited it to make it look real. And then we all think it's news, right?
It's crazy.
That's definitely the wild part, is like almost how do you think AI will be put to use in kind of like trying to analyze, I guess, do forensics, essentially is what it is, digital forensics, to figure out if it's propaganda or if it's real.
Yeah. Like, is this Putin speech really him, or is it an AI deepfake, right?
Well, speaking of Putin, there's a clip circulating of him being shown by Russian scientists used AI to examine the moon landing footage, and this AI said like 80% of the footage is fake.
Weird.
Like, and he's like, So it's like, but that's kind of the thing. Is like, what about footage from 60 years ago that changed history, but AI analyzes to say, hey, it's fake. What do you do about that, right?
So, and where do you need to intervene? Like,
are there machines watching the machines, I guess, is the question.
Yeah, you ought to have machines watching machines.
Yeah.
Going back, you ought to. You really ought to. If you're being responsible and you know these machines are out there, you need to have machines watching the machines. I give a plug for my friend's startup called Run Sybil, which is about trying to automate hacker intuition. So there's this idea, it's an ambitious one, right? That machine learning right now can learn patterns quite well. So if a certain hack, if a certain attack has been executed over and over and over again, and this answers your question too about recognizing whether something's propaganda, if there's a statistical pattern in language data, image data that suggests it's propaganda because you've seen lots of instances of it from the past, then you can identify it as such using supervised learning, labeled examples, right? And that's also something that's commonly done in financial fraud in combination with unsupervised learning, which is where you just look for outliers, even if you've never seen that type of attack before. This is a fundamentally different thing. So this is, can I get the machine to come up with novel strategies for attacking? So it's red teaming again. So we're trying to come up with how to probe the vulnerabilities of the system, whether it's a human mind or whether it's a computer, right? Find ways to extract what one wants for that or put in what one wants to put in, right? And silently escape, right?
Wow.
Banks have done that where they'll pay hackers, or usually they do it with bank vaults, right? Can you break into my bank? And if you can, I'll pay you, right?
The change is, can we get what has traditionally been really thinking work, on the part of hackers and start to automate that, so we have machines probing, trying different strategies, trying to automate. Um, a hacker doesn't just naively try strategies. They're not what we call brute force in computer science lingo. They are thoughtful and clever. And can we get machines that try to generate hacking strategies or propaganda strategies to be more clever about it? Well, so that's an offensive capability, right? But if you can kind of solve that problem, then the adversarial part becomes easier, right? Because now you can use that capability for your internal red team. So if you are the NSA, and you want to keep an eye out for propaganda attacks of all types, well, if you're good at generating them automatically, then it should be easier to blue team those, because at least you can automate the process of finding clever ways you might be attacked. Right?
Mm-hmm.
So your capability to create propaganda is simultaneous with your ability to counter prevent.
I think so. And that's what you might call the generative.
It's kind of dangerous.
It's the generative / adversarial relationship. So there's this machine learning idea called a generative adversarial network. It's a type of neural network technology. And it learns how to generate examples, right? And then it learns how to, say, tell if that image is fake or not. And then as the classifier for if it's fake or not gets better, the generative part gets better at creating a more and more realistic face, because it's trying to fool the counterparty. And
sounds like a debate.
Yeah, I don't want to,
Well, they're already in competition with each other. I mean,
yeah. It's akin to, it is not the same as, but it's akin to that notion of self-play from AlphaGo, right? Where you're playing games against yourself. Maybe your algorithm starts off by learning to play Go by playing against a lot of very skilled people.
Yeah.
Or, examining past matches and learning probabilities of what happens given the previous state.
Mm-hmm.
But what you might do in this context is, self-play is learning to fool the counterparty, get the deep fake past the, the deep fake detector.
Yeah.
And then both of them get better by playing against each other. It's self-play with two counterparties.
It's wild.
Yeah.
So definitely, because it seems like we're shifting from the financial side to this kind of like visual propaganda,
Creation side,
audio.
right? Yeah.
Definitely, I'm an artist, and you have a music background. What's of concern to me and a lot of other artists is when AI is doing things like, and I mentioned it earlier. There's a gentleman who, him and his group programmed this AI to use probability and sequence to create songs, unique songs. And so it's running every day, creating millions of songs. Thankfully, this guy is copywriting it in the public domain, so that protects it from someone doing that in the future and saying you can't use there's no songs that you can create because I've already created them and patented that. That's definitely like what now?
That's wonderful. You told me about this before, of course, off camera, but it's just striking me. That's an exact example of what we just talked about.
Yeah.
Of using this generative capability, which you might see as offensive if you were trying, say you were doing the opposite and making them private. In this case, it's a defensive capability because he's making them public.
Right.
Right.
Right. And it's really, I don't know, it's concerning, at the same time hopeful. What are your thoughts in terms of, do you think AI can really breach into that artist world? Do you think it's something we should be more concerned about? Or, I mean, kind of going back to a human element, is art and creativity, we create them to enjoy because we're physical beings, we enjoy them in a biological sense. Do you think there's a risk of that? Or do you think that, based on your understanding of AI and it's how it's data and binary, do you think it can really grasp and capture that essence of art, and could it take over, let's say, human creativity?
No. It's actually very akin to, if we just go back to the idea that AI is very powerful, very strong, very smart in a narrowly defined way, but in another way is fundamentally, not that impressive, lacks common sense, lacks wisdom. AI can take a huge corpus of music, or for that matter, language that's already been created
Yeah.
by human beings or by other AIs, and it can get better and better at imitating that music. And actually, imitation can definitely appear creative and be creative in the eye of the beholder in this sense. But this is another thing where it's like the mathematical model really empowers the creator. I'm not trying to paint a picture that's too rosy here. Like there will be no negative repercussions of AI in the music industry, because I'm sure there will. But in general, just like financial machine learning requires human supervision, this time
Yeah.
we're thinking about risk. It's much different than the process of creating music, But
My head always goes to like the input factor, because to think about it from a movie point of view, people have directors they like. You like Scorsese, you like Kubrick, you like Tarantino. It's sort of like 25 years from now, will it be like, I love that AI's movie, right? And then it's like, who programmed that AI to make a certain type of movie, right? So in other words, like if somebody, let's say Scorsese creates an AI to make Scorsese films, you see what I'm saying? So it's like,
You still need the human input of
You
like
still need the
AI
human
couldn't
input.
have made a Stanley Kubrick movie or a Quentin Tarantino movie.
yeah.
But now that it exists and a human did it,
yeah,
it can now create
My
more
favorite
things in that
director is so and so AI from Tokyo who makes movies I like. You see what I'm saying?
so this is where the
Yeah.
it's in the domain of language, not music. Same concept though. This is where the New York Times versus OpenAI lawsuit is very relevant, right? Because it's one part of a society-wide debate we're going to have about intellectual property in the age of generative AI.
Yeah. Tell us
And-
about that lawsuit. Just a primer for people. So
Yeah, I'm not familiar with it.
Oh, do I know all the details of it?
Just the
It's
general-
something like this. It's something like this at a high level. OpenAI used the New York Times' intellectual property in training its large language models.
I see. New York Times said no.
That's the allegation.
Yeah.
Right?
You have to pay us for that.
You have
right?
to pay us for
Yeah.
that, or something along those lines.
Mhm.
So the reality is those models are trained using huge amount of information. Couldn't tell you exactly what information. I don't think it's public knowledge.
Yeah.
But by querying it in certain ways, I believe what the New York Times did is they queried ChatGPT a bunch to try to get it to spit out words from New York Times articles.
Interesting.
Verbatim,
Yeah.
kind of like you would approach plagiarism.
Mhm.
Are they copying? Is it
Yep.
close enough to this one? So it's like that. It's looking for evidence that it copied their intellectual property. And you could apply the same thing to music. Did you copy my melody? It goes to what you're saying about the
interesting.
guy putting things in the public domain to
Mhm.
protect those melodies, which may one day be written, right?
Yeah.
Right.
Yeah.
Well, and that's the tricky thing about art is, I mean, even the human brain, because we are inspired and then we recycle. I mean, our last guest talked about adaptation is essentially that of like,
Mhm.
we are all seeing and experiencing things that are not ours, and then our minds each do a different job of arranging that in such a way, and some people are better at it than others. At once they've arranged it, they put it out, and then it has an effect. It definitely seems like it would be very tricky for AI without essentially just robbing everybody, but essentially doing the same process we do as artists. So it's kind of strange to fault what they're doing when we are all guilty of it at the same time, right? Sometimes simultaneously, two people across the globe invent the same thing, and
Yeah.
it's like
You're
know,
subconsciously borrowing sometimes. You don't
right.
even know.
You don't
it,
even
right?
know where
Yeah.
that came from.
Yeah.
What are your thoughts on, especially like the ability of AI to do you think it will be possible that an AI could have true creativity, like in the way that we do?
You know who has a good opinion on that is a author named David Cope, who created, I say author because I'm thinking of his book, but fabulous musician, fabulous programmer, created something before the era of generative AI as we know it right now, but definitely generative AI. His project was called Experiments in Musical Intelligence. And it was an imitator, right, originally. And he spent his career, first it's just this fascinating discovery. I created this thing that looks at the corpus of all of Bach's music, and it created music that sounds like it's from Bach. And guess what? The music professor can't tell the difference. That kind of thing.
Yeah.
And so it's like, wow,
Yeah.
that's incredible. And then his follow-up was what you said, Ben. So he's like, you know, the rest of his career, I think, is about that question.
Yeah.
And I wish I could revisit his book right now.
Sort of that, how much is derivative versus original, right?
Right,
Like,
because especially with the consumer market, like there's pop, mainstream, right? What's catchy, the same reused chords, but they know how to make it sensational, so people listen to that. But then there's like real music lovers or musicians. There's music for them when they are looking for uniqueness. They're looking for a creativity or something no one's done. And so kind of I think the worry in the music industry and a lot of the movie industry as well is like the wider consumer market's easily fooled, and they maybe even, especially if these AIs are creating things that are taking into account that sensationalism of kind of taking over your biology and your attention, that pulls away from the next Bach, right? Who is not your everyman's taste, right?
Music industry is always, well, not always, it's changed, you're right. But there's been a problem of signal and noise just amongst competing humans, right? But there's a sorting process of preferences of consumers that somehow digs through the infinite bins of artists, and also marketing.
Besides, they like this version of this.
And
right?
in the end, when we look at the success of musical artists, it's what do you call it, Pareto distribution of like if you had a quantification of how well that artist is doing, like a number of albums sold or the gross revenue from their say all their albums over a certain time span, something like that. Those success measures will have a distribution that's a curve like a L shape, right? So there are very few people that did amazingly well, right? It's the same distribution. This is where it comes from, is the concentration of economic wealth, right? The concentration of assets was what the Pareto distribution first described. You see that same distribution in the success of artists. Somehow we arrive at that distribution from the inputs of lots and lots of people making a lot of noise, but the signal gets extracted by market preferences. That wouldn't be my definition of good, by the way. I think the stuff that I would like would probably fall on the definition of, on the profitability distribution. It'd be way, way off in the distance,
Right. I mean, and definitely you have genres, like I think we'll see an emerging, in music specifically, this emerging genre of something so out there that only a human could have done it. You have experimental jazz is that way.
Yeah, I was about to say,
just a bunch
jazz
of chaos,
is kind of,
and people playing off their intuition with each other, and it creates sometimes those artists, they don't ever record it, so they can't repeat it, right? What you experienced in that concert was there in that concert, and it's not somewhere else. I think. Do you think that we'll head back towards that way where our taste will go, I want something that's not that. I want the chaos.
One of the interesting operationalizations of musical creativity that I learned about talking to a researcher named Psyche Louis. I may have to go back and correct her name.
Yeah, you've given us quite a few. We're gonna have to put some links in the video, but there, a lot of good resources here.
Talking to her, she mentioned a definition that she had worked on in her lab, which was it was kind of almost a reaction time. It was like the time to come up with a musical phrase, something like that. I'm sure that would be corrected if you actually went and looked at her paper. It is a finding that jazz musicians are faster at that than classical musicians, right? Which makes sense, given what they are trained to do.
In hip hop, it's freestyling, right? There's people who write good raps, and then there's someone who can sit there on a radio interview and drop 5 minutes of bars just off the top of their head, right? And I think that's kind of like what you're pointing to, is the ability for some people to at random create at a higher pace.
So then say you have human judges. They're going to talk about whether that musical phrase that was created in 497 milliseconds instead of 725 is that phrase novel? You know, at jazz concerts, there's this like, oh thing. Okay, well, skeptically, is the oh a response to creativity? Or is it really just that every time they get to the secondary dominant, or they get far enough outside of the implied key, that dissonance excites everyone, predictably?
Yeah,
Because
sure.
their
But-
prediction was
but-
wrong.
but
They're like, oh,
I think it's more interesting, you know. So I think musical enjoyment is predicated on a combination of satisfying existing expectations and surprise.
Yeah.
And jazz and pop are opposites on the spectrum, right? So I really do think the jazz audience is looking for the surprise. So if they've always heard the secondary dominant, that flavor isn't going to appeal to them.
Yeah.
And that's how you get to the extreme of free jazz, maybe. I mean, you could think of that as a process, looking for more surprise.
It's all
takes
about
you to free
context,
jazz.
right? And sort of
So if you're all inspired by free jazz, we might have a little bit of
yeah.
a counter approach to AI, making everything sensationalized and predictive.
You might end up going around a circle of of what's surprising, and you all of a sudden you play pop in the free jazz concert, and everybody, oh, we haven't had anything that surprised us for years.
Depends on your data set, right? You have a different data set than I do.
What's your reference data
Yeah.
set for surprise?
Yeah.
Right. And one advantage pop music has is you know, we respond to familiarity very well, and so the corpus of what's familiar is what cultural context is how this is studied in ethnomusicology. The frame of reference for like what the emotional affect of a given key signature is, like say a minor versus major in the like most simple distinction, or a certain way of tuning, right? The way that that is related to an emotion or an image varies culturally.
Yeah.
And those expectations are, they are not the data set, but the statistics over that data set. That minor third means sad is in some way a statistic over the data set of music that we've been exposed to, and then the cultural context of that,
Yeah.
of that observation. So we have observed the minor third over and over in a context where
Associated with-
implied sad.
Yeah.
And so eventually we learned the implication minor third implies sad.
Yeah. It's like we know what suspense music is in a movie.
Yeah.
We know what, thriller music is or whatever. It's like, when you hear the certain music, the killer's going to walk in.
Right.
Yeah.
But then we want to play with that. So if you're making music that's supposed to be interesting, you're not just gonna satisfy the expectation. You're gonna know it because you're informed and clever, and you've been studying, and you're gonna toy with people's frame of reference.
Yeah.
Like Quentin Tarantino, we talked about in the last episode of Inglourious Bastards, where historical context you're led, and then all of a sudden at the end of the movie, whoa,
Different ending.
That's not what happened historically. But at the same time, you're like, yeah, that's how it should have happened. Like, I definitely see what you're talking about, because like a true brilliant creator in the future will be playing with those pieces of like, if it's all figured out, what's the next thing to figure out, which is how do we surprise people? How do we change or even shift the listener base?
There's a parameter in large language models called temperature that's become a convention. It's like calling it temperature, and it's how random the output is.
Interesting.
So you relate it to word probabilities, note probabilities,
Yeah.
probabilities of a musical phrase. If you have a generative model, you can crank the temperature and it will create stuff that is more novel, surprising, interesting,
Yeah.
random, because it conforms less to the distribution that you're used to. The distribution meaning the probability of certain outcomes, probability of a certain sound, probability of a certain phrase. Given you said this, I think you're going to say this. So
Yeah.
that would be like the most probable, response given a certain call, right?
Yep.
Temperature makes things random. Temperature, as you turn it up, causes things to diverge, right? And so there's a built-in way of thinking about maybe not creativity, but at least thinking about the degree of chaos or the degree of randomness.
Novelty.
Yeah. Well, it could cause novelty. Novelty is kind of a perception, right?
From what I understand, and I referenced this gentleman, Terrence McKenna. I don't know if you're familiar with him. His novelty theory is the idea that the universe creates the randomness and the chaos we see is, he thought, as novelty, that it's creating something new and ever more complex. And so it's a process. So the randomness is random, but at the same time, there's a process to it, and that the reason for that process is novelty, so that we're always generating something new. But it seems like chaos, if that makes sense.
It does, and I think where AI could be helpful in creativity is with breaking some of these molds that we've learned. I'm a big movie guy, and so many movies you see are repetitive formulas, act structures. You expect plot points at certain times, and that's because that's the proven model that makes money in Hollywood, right? There's a lot of big budget films that follow the same 3-act structure. We've gotten used to them, and that's what makes a lot of films dull and less exciting. Something AI might do is create some more original story structures or new paths that then artists can take and implement, right?
So you're saying models for creating
yeah,
something
or
versus
say,
like specific plot
rather
points.
than making the movie, AI will tell you, try this as a new idea, as a point of originality, right? And that's something I think AI might have the power to do that Hollywood seems to struggle with. I mean,
So back before the current era of AI, something we used to do with music is there are these really simple statistical models called Markov models. And they just tell you, given that you're at state A, what's the probability of transitioning to state B? So you can apply that to some notes, right? And you say, given the last note was this, what's the probability you go to this note? And then, say in conjunction, you do the same thing with quarter notes, half notes, 16th notes.
Yeah.
So you end up making some random music. The fun and the benefit being you can make a lot of it. And then you can kind of sort through all your little generations, or you can let these things run for a while and listen to it in real time. And the novelty's in the eye of the beholder, because I observed all this stuff being made for me.
Yeah.
But then I'm the DJ, I'm the critic.
Yeah, you're the editor.
I'm the evaluator of novelty and the decider of quality.
Yeah.
That's
the future.
Fun.
I think that will be a lot of the future. I think, and how AI is used.
Yeah, turn up the temperature on a generative model.
Yeah.
Get some seemingly random stuff in, because you don't want it to just click past stuff.
Mm-hmm.
And then decide if it's good or not. Be the evaluator. And then if somebody can automate that process of evaluating, that's another level, and that's really cool too. I'm sure there'll be some work.
Well, this is a huge conversation in Hollywood right now between the Writers Guild. You had the strike, and a lot of it was about that sort of how can AI be used. It can't, we can't have it eliminating writers, or shrinking a writer's room from 10 people to 2 people. So a lot of that strike was about that. And they found a stopgap, so we can keep the business going for a few more years. But there's still a much bigger conversation that's going to have to be had in Hollywood in regards to creation and how AI and automation's used, and, making sure artists are still employed and paid fairly. So that's a big conversation to be had.
I think we take a quick break and get up to it and close up.
Sounds like a plan.
All right, and we are back live. One thing kind of you mentioned earlier, you definitely wanted us to rein it into how all of this is relevant to our podcast. Being the Post-Truth podcast, I was definitely inspired by a number of things, but there's one TV show I watched a while ago called Westworld, and kind of that idea was, part of it was how this mad scientist is using AI and to get at the root of what is human consciousness, how you generate consciousness. But later in the show, as they move beyond that, the idea is there's this supercomputer, right, that tracks everybody's lives, their credit score, their personality, all that data, what's good for the world, and what should that person do in order for the whole. And I think that's, people think of that in an apocalyptic kind of connotation. And we talked about it a long time ago. I think you called it an oracle, right? That there's this idea that people might input all this data, and then as it gives us that answer, that prediction, it creates the script, right? And so that's what everybody's kind of worried about, is that there will be this point where AI's flooded everything, and that even your personal AI is more like giving you your orders versus you being the one with the reins, right? And so what do you think the probability. I mean, not probabilities. That's
Mhm.
what are your thoughts on like the danger of us
possibility,
using
maybe.
this as
Yeah.
you know? Do you think people are trying to build towards a point where we kind of have this AI god that
Well, you've already
takes in all
started.
of our data
Yeah,
and then and predicts it what down to what every single person should
Yeah.
be doing with their lives?
So one thing is that you can't derive a should, from a prediction. Should imparts some value judgments
Mhm.
about the world. What's a desirable outcome?
Moralistic and value system and things like that, right?
Yeah, value system.
More philosophical questions at that point.
Philosophical questions. What's good? Which was, sort of at the origin of philosophy, right? That
Yeah.
some of the earliest texts are, you know, what's well-being. Okay,
Mhm.
we have hedonic well-being, eudaimonic well-being. This, but before we have questions of optimization of decisions, optimizations of actions, the oracle idea is just sort of, an unrealistic expectation of what we could possibly get out of prediction. It's what if we could answer any question with perfect certainty because we had a perfect understanding of the universe. One way Douglas Hofstadter put this, which I think was really good, and Gödel Escher Bach, was imagine that you had a equation that described where all the particles in the universe would be at the next step in time. If only you knew where they were in the previous step. This is like a physics way of modeling things, like a differential equation. So he's imagining you had this differential equation for everything. You could predict the way the universe behaves. What does it even mean? Well, that model doesn't tell you what it should do.
Yeah.
It tells you what it does. And
Interesting.
that's a problem because, in that model, there's no free will. So we don't even get to say what it should do. It just evolves.
Deterministic, yeah.
It is.
Yeah.
It is what it is.
That's where like the quantum computing with AI could become scary because I mean some physicists think of the quantum space as this you actually can glimpse into what will happen or all these possibilities and then you then have like a human agenda of like what possibility do we want to bring into reality, and not so much even that let's say AI could be capable of giving us that oracle, but I think everybody's worry is that someone's going to create an AI that they convince everybody is telling you the answers when in reality it's receiving the bias and the agenda of the person.
Especially if no one
putting it
has
into
the
place.
reins, right? That's the big
Right.
one, right?
So those questions about misguided use of AI are what we encounter, of course, on a smaller, less universal scale. I think what you've told and that narrative which occurs over and over in film and in literature about a godlike artificial intelligence that runs the lives of everyone is mythology, right? And so I do think that this idea of superintelligence is overblown, but is not totally unwise because it's repeating a mythology that we've had for a while that's been in our culture about what happens when computerized decisions run our lives. And all of the high-risk applications of machine learning, like credit risk, carefully managing those systems, right, is about avoiding that very case that you're talking about. Not the mythological version, but a smaller, more realistic version, which is things like when teachers are being evaluated by an algorithm that is not transparent, that can't explain why it made a certain evaluation, and that all of a sudden decides that the best teacher in the school who improves the lives of every third grader who comes through his class is, fired on the basis of this decision.
Yeah.
On the basis of this prediction.
Data, yeah.
And we don't even know what it was, but, and here's a human assumption that goes into this process, making it a bad thing.
Yeah.
The computer said, and the computer must be right.
Yeah.
It's data, it's factual.
Yeah.
No. We need to very carefully control what we tell the computer to reason about and on the basis of what. What data to answer what question. And then we need to be able to question the way it made the decision
and contextualize the output of it, right?
Yeah.
As well.
And if we can correctly operationalize the way that we would like to think about decisions, on the flip side of that, we have a tool that can make our thinking a lot more rigorous, like in applications like hiring, where you don't want somebody making a hiring decision on the basis of their personal opinion and how they felt and their impulse and their mood that day and whether they had coffee. That's not fair. That's not right. Right? But one step better is all the reviewers have a scorecard and they score the person on these different attributes, and they decide at the end, they pool the judgments, and there's a mathematical formula for doing that. Say they take an average, and if it's past a certain number, you're hired. Okay, that's more fair. Well, statistical model, once we've really got a good process going like that, and we know the basis for the decision is fair, can help us remove the bias of the human reviewers and help us avoid using human discretion in applications that could negatively impact people's lives.
It's interesting. It's a balance between the two, right? It's like, got to have that good model, the good input, and then you've got to be able to evaluate the output with the human element. I mean, it's, as long as we maintain that balance, we should be okay, right? I mean, that's
what I feel like.
Avoid the worst outcome.
My bias is I'd rather carefully design a system to work well that I know is reliable and I understand how it works than to rely on kind of the almost heroic or exceptional qualities of, say, an individual hiring manager to be really good at interviewing in order to make the hiring decisions good and profitable for the company and also fair to the applicants. I would like, if I can, to formalize that process, to make it repeatable, to make it consistent. Yeah.
Well, great. I think we've had a great podcast so far. We're really thankful that you came on today. I will say it's like, I think from what you said today, I definitely feel more hopeful about, for one, the limitations of the fantasies people have of AI, but also that there's people like you in the field that are, whether they know it or not, are combating this kind of critical mass point where AI is running things based on bad judgments, based on bad inputs and biases. So yeah, I'm really happy that we spoke today. I think it will give our listeners a lot of insight into AI, maybe point them in a new direction to look into, a new way of thinking, and maybe a little bit less sleep lost at night over it.
A lot of great resources you've given us too.
Yeah, for sure. Is there any place, whether it's your social media or a website or some type of portfolio of your work that you want to direct people towards, or LinkedIn?
I'd say LinkedIn. Actually, yeah, that's what I'd say. I think LinkedIn is a really great place to join the discussion about AI. I tend to like a lot of posts that I think have good points. Sometimes I may not even fully agree with that post. I just think they're asking an interesting question. And I have other people that I follow on LinkedIn where I kind of religiously try to pay attention to what they're paying attention to. You know what I mean? So, yeah, that's what I'd say. LinkedIn.
Gotcha. So follow Sam Fisher, and your last name is Fisher, or does it have a C in there?
No C.
No C. Okay. So Sam Fisher on LinkedIn, if you want to stay up to tune on what he's looking into, kind of the things he's paying attention to, that actually is a really great advice for me too. So I'm probably follow you on LinkedIn and kind of see what you're looking at, and that will help me, kind of keep a thumb pulse on the scene.
Likewise, because I want to know where things go with music. I'm a little too abstracted from the music use case, and you're right in the middle of it.
Yeah.
So I'm fascinated to see where you go with that.
Well, for sure. Any closing words, Johnny?
Thanks for being on. Great conversation.
Absolutely.
Thanks for having me.
And this is extremely dangerous to our democracy.
This is extremely dangerous to our democracy.